Today's talk is mobile performance optimization or mobile performance considerations. And just about the slides, first of all, they're up on GitHub. They will be up on GitHub forever, along with all of my other presentations. So I'm going to refer to other slide decks, because sometimes I just don't go that far deep into topics. But there's a whole hour on it on my GitHub. So my name is Estelle, and that's all you have to remember, because supposedly I am the only front-end engineer named Estelle. And so I have my own GitHub with Estelle, my first name, which is kind of awesome. And just go to estelle.github.io, and there's about 30 to 40 presentations there. So basically, we have a problem. The average website right now, because I made this large enough for you guys to see, is 1,944 kilobytes. That's a huge site, right? That's crazy. And people are sending the exact same files, if not more files, down to the mobile devices. So they'll be like adding a media query and changing out 2 images, and they think, oh, we have a mobile site, or they'll be making it squishy. Making a site squishy does not mean that your site is performant. It just means that it's squishy. So we're going to talk about tips and tricks to make your site actually work on mobile devices. So when you have a 2 meg site, well, you shouldn't have one, but what you need to do, there's a few tricks that are obvious and well known if you know anything about performance. So I'm going to cover these quickly, and then I'm going to go into some little quirks about mobile devices that will make you think a little bit more about some of these. So if you're doing web performance optimization at all, desktop or mobile, you always want to put the style sheets at the top. You want to put the JavaScript at the bottom, because putting the JavaScript at the bottom or at the top, it's still going to take the exact same amount of time to download, but the perceived download time will be much faster. You want to minify everything you can, including gzipping. You want to reduce the number of DNS lookups, and you want to cache everything you can. If you are very new to mobile performance or web performance, there are 2 tools, YSlow and PageSpeed. I recommend taking a look at both of them. So what that looks like when you're developing a page is, very simply, title, the next thing after your title should be your CSS, and the last thing right before your body tag should be your JavaScript. And if you want to, you can include the defer attribute down there, so that you definitely say, don't hold up my site while you're doing this. So YSlow has a bunch of rules, and these are all rules you should follow no matter what. I already listed some of them. Some of them have to do with input-output. PageSpeed was basically written by the people who wrote YSlow, so it's the exact same thing, but on crack. It has additional rules to follow. If you want to learn more in depth, you can look at those sites, or actually, these slides are a little bit interactive. If you want to take a look at these later, you can click on them. So let's get into what is different about mobile versus your tethered device. And by mobile, I basically mean a non-tethered device. Most of you, who here does not have a cell phone on them? Okay, so everyone here has a cell phone on. Who here is tethered, is charging their phone right now? One person. So the rest of you are assuming that your battery should last at least till the end of the day. You want it to last 3-4 days. You don't want, as a developer, to drain your user's battery. They're used to knowing that when they are playing their video or FaceTime, that they're draining the battery. But if they're looking up, buying something on Amazon, or checking their Facebook website instead of the Facebook app, they don't expect you to be draining their battery. Then there's latency, which is a major issue. Memory, because we have these small devices with super powerful browsers, but very limited memory. And then you also want your sites to be responsive. And when you're on a mobile network, your sites by definition are less responsive. So basically, you need to remember that your phones and your tablets are not laptops. They're not tethered. So the first thing I want to talk about is the battery. Now, this is my analogy for the battery on a phone versus a computer. Your computer, just like your car, is kind of always charging. When you're driving your car, you're recharging your battery. When you're sitting at your desk with the plug in, you're recharging your battery. I am not currently Oh, it's not in my back pocket, it usually is. I'm not currently charging my phone or my iPad right now. But I'm also not doing what I usually do with batteries. When I have a battery that needs to be recharged, like in my flashlight, I turn my flashlight off when I'm walking between rooms. People think that they're turning their phone battery off kind of when they're turning their applications off, when they're closing out, going from one application to another, but they're not actually. So you don't have to be responsible, but I'm asking you to be responsible and think about people's batteries. So there was a study that was done by Angela Nicora and some of her graduate students, I believe at Stanford, and it was called Who Killed My Battery? And it's definitely a too long didn't read because it is a study, but the general idea is that there's certain things that really use up batteries. One of those is images. Images take a lot of CPU to render, and you don't really think about that. But another thing is JavaScript. And every time you include a JavaScript framework, be it jQuery or Sencha or any other framework, if it's included on the page, even if it's not used or not downloaded, it is still parsed and executed with each page load. So you might be including some libraries that you're not even using. And you're thinking, oh, that's not wasting battery. But it's parsed and executed every single page load. So you really do have to minimize the amount of JavaScript you're using. And one of the interesting things is jQuery was basically developed originally because of IE 6, 7, and 8. And when you're talking about mobile devices, you're not talking about not knowing what an add event listener is. Every mobile browser knows what an add event listener, what that means. So you don't really necessarily need jQuery. They understand query select or query selector all. So if you're doing it just to get the $sign, you might not need to include jQuery. jQuery is a very small library, but if it's parsed and executed on every page load, you're draining the battery. So I want to talk a little bit about images. The blue up there is parsing, decoding an image that is not correctly sized. So if you do a background image and you put size contain or cover instead of auto, the bottom is auto, the top is either contain or covered. It was a study done by Microsoft. I'm not sure which one they used. But if you notice the blue, and you can actually see the color, this is great contrast. Usually I don't have such good contrast. That is the CPU being used. When you're using the CPU, you are draining the battery. So I pretty much said all of this already. But if you want to hear an hour explanation as to why you shouldn't include frameworks into your mobile sites, I actually did a talk called You Don't Need a Framework for That. And there's a video of it, and the slides are at my GitHub. So to summarize, battery consumption. When you use the CPU, you're draining the battery. So you want to minimize your usage of the CPU. You want to avoid reflows, and I'll talk about reflows in a bit. You want to minimize JavaScript, both the number of JavaScript files you're including, the size, and the activity. Use CSS for animation, except for really complex animations. So there's a tipping point, and I don't know exactly what that tipping point is, but if you're just opening up or moving something across the screen, use CSS animation. Your browser is optimized for CSS. If it's really complex and you need to use WebGL, then you're probably supposed to be using JavaScript. But avoid using WebGL if at all possible, because it does use a lot of battery, even though it is put on the GPU instead of the CPU. Implement what you learned today, if you learn anything, and avoid loading resources you don't need. And basically manage your memory. So next I want to talk about latency. And we all know about latency as being an issue all the time. But latency is a bigger issue for mobile when you are hitting a cell tower than it is when you are tethered or using Wi-Fi. Because this is normally what happens. When you make a DNS request, this is simplified, but it goes from your computer to the DNS server, says, hey, what do these letters mean? It returns an IP address, then your computer goes and asks for the IP address, and your site is returned. When you're on a mobile device, and I like the archaic phone that I used here, it's slightly different. Because, first of all, when your mobile device is not your mobile device radio goes to sleep. So you have to wake it up. So step one is waking up your radio, which can take hundreds of milliseconds, if not seconds. Then it doesn't go directly to the DNS server. It actually has to find the cell tower. The cell tower then communicates with the phone company. The phone company then gets the DNS. The DNS replies to this phone company, replies to the cell tower. The cell tower then tries to find your phone. Then your phone's like, oh, great, I have the IP address now. But it already went through all those steps. And most of the latency is in the ear between the mobile browser and the cell tower. Then it has to go back through the cell tower to the phone company to the server that's actually hosting the website. And yes, if you improve your server so that you are serving a page in 2 milliseconds, that's awesome. But that's not helping in terms of, that doesn't do anything. So you can optimize all you want on your server, but you need to do a lot of optimization so that you're not asking the cell tower for too much information. Okay, so how do you reduce the latency? You don't do redirects. The number of sites that are doing 3 or more redirects right now is 70% of the top 1,000. So when it's redirecting, it's asking for another DNS lookup. Then you can do things like reduce requests. And here's a sprite. A sprite, for those who don't know, is one image that contains a lot of multiple images. So you're doing one HTTP request, and then you're just showing sections of that image in your website. So Sprite is a really good idea. And I'll talk a little bit about the drawbacks of sprites in a little bit. So the best practice for desktop that we looked at earlier was sticking in a CSS in the top and putting a JavaScript in the bottom. What might be better for mobile, and not necessarily always, you definitely want to have external style sheets and you definitely want to include your JavaScript as a defer, but sometimes it might make sense to include your style and your JavaScript right in the first page load. What company was it? It was Bing that did this. Bing took all of their content for their search when it came to mobile, and they stuck it all into the first page load. And then they gave each one of those styles and JavaScript files, which were included in ID. They took it out, put it into local storage, and then for every request, every HTTP request sends cookies back and forth anyway. So they just said, basically, let's actually make this useful. And then they would send the IDs of the files they already had saved into local storage and say, hey, I already have these, only send me the ones I don't have yet. So they put everything in local storage and cookies. And the first page load was 226 kilobytes, which is smaller than the average site nowadays. But their subsequent requests were only 19.56. And every single request that they did, page load was only one request. So this might not be manageable for you, but it's something to think about when you're doing development, that there are alternative ideas to reduce the number of HTTP requests. But if you are loading up 226 K, and do you remember that stat from the first page where it said that it was 1944 kilobytes is the average site? 60% of those are images. So when you're sending that much, you're using up memory. When you use up a lot of memory on a mobile device, or any device, it causes your UI to slow down. And on a mobile device, unlike your desktop, which can reallocate, your mobile device browser will just crash. It crashes to free up memory. So you don't want to make your users run out of memory. So let's talk about memory on mobile devices. So my first mobile device was the original iPhone. I believe it had 128. Now, so 128 megs, it's not much. We went up to 256. And then the iPhone 4 or 5 came out and it had 1 gig, and that was awesome. And the thing is, it's not increasing. The 6 that just came out, it has 1 gig. My cell phone has 768 because I have a very old HTC Inspire. The iPad 1 came out with a 1/4 gig. The most recent iPads, 1 gig. But notice the Samsung Galaxy Note Edge has 3 gigs. That's a lot of RAM. But the most popular phone in India, because it is the cheapest phone in India, is a Firefox, the one that's, it's not necessarily the most popular, but it's the one that's increasing in sales the most right now, is the Intex Cloud FX, which has 128 megs. That's not much RAM. So realize that when your users are using their mobile devices, they're running their operating system, they're running all of the applications that are running in the background, they're running the browser, and then on top of that, they're running your website. So this was my HTC Inspire. I can't update this very often because I usually buy used phones for my my mobile. I have a wall of devices at home. But this is what it looked like when it was brand new. And you can't read it because I use tiny, tiny, tiny little fonts. But it had 255 megs, or 128 of megabytes available. So that is how much space I had available for running all of my applications. Not one of my applications, but all of my applications, including the ones that are sending me push notifications, including my browser, and including your website. So there's not much memory left over on those tiny meg devices. So with that in mind, is a sprite the best choice? A sprite this size is fine, but you don't want to go over a certain file size. It used to be 1024, and I haven't crashed a browser in a while, so I'm not sure how big and if that's changed. But what happens is if your image is too big for the memory, it will actually tile the image, and that uses up 4 times the amount of memory. So you can gzip your images, and they become small and they're really fast to go over the wire. But what happens is when they're on the device, they're deflated and they're the same thing as the original size. So you really want to reduce the original file size. There's some tools to do that. On my Mac, I use Image Alpha, and that's because I'm not a designer, and like to me, I never actually see images lose quality because it looks fine to me. So your designer might disagree with you, and there might be a perfect point, but shrink your image as much as possible. Just by sticking this gzip icon, I went from, I saved 64%. There's other tools, like this is Sencha, which they bought TinySource, and you can link to an image. The only thing is that increases that makes an external HTTP request, so DNS request. So you have to decide, like I'm not going to give you any exact answers, but you always have to weigh what you're doing. So if you have a huge image and you don't have the resources to provide the right file size, you can do another DNS lookup and use Sencha. This is the stats for that big image. That big image was 724 kilobytes, and it resized that image to 19K for my phone, which I was using an iPod that day. Okay, but remember this image that I showed you when it uses the CPU? There's another thing with using the right size image. So if you're going to have a squishy website, choose 4 or 5 different image sizes. Don't have squishy images. Reason being, you see how long it took for that image to be decoded? Whereas on the bottom, how it was decoded really quickly? It takes about 50% longer to decode an image that is not sized at its default size. So I created this thing called the clown car technique. I'm not sure if any of you have heard of it, but the idea for responsive sites to do one HTTP request is to actually stuff all of your images, all of your raster images, into an SVG file, and then serve that SVG file. And you actually, the only request you have to make is to that one image. So here you see as the page is shrinking, it's changing images. So I'm basically making the black line that is flashing in and out is basically me, I'm shrinking that page. I'm shrinking the width of the page. The reason the clown car technique is kind of a good solution until the picture element is supported. And if you guys have heard of the picture element, it is being implemented right now. It is out on Chrome for Android. It's out on Chrome, and it's out on in Opera. It's behind a flag in Firefox, but it's the only mobile device it's on right now is Chrome for Android. So the reason the clown car is actually a good stopgap measure is because it uses up one HTTP request, and the size of the image, the media query of the image, is based on the size of the image, not the size of the page. So you can actually shrink your page different amounts, but when you shrink that image, that's when, but it uses an object tag instead of an image tag. But it's based on the width of the object, not the width of your device. Usually media queries are based on the width of your device, and the clown car technique is based on the width of the container that's holding it. Okay, so we talked a little bit about media queries. Use them. Feed the right size images to your to the device. And here I'm using numbers that are basically that everyone always uses, which is 480, which is the old, the original iPhone, and 960, which was the original iPad. You don't need to use those particular images in sizes. You shouldn't use those sizes unless that makes the most sense for you. And what does make the most sense for you mean? Take your design, squeeze it down, make it squishy. When it doesn't look good anymore, that's where your breakpoint is. Your breakpoint is not because of a specific device. Your breakpoint is based on your design, your layout, and your content. So, I added some resources in terms of media queries, which ones are most useful for doing squishy layouts. We have viewport width and height, screen width and height. If you actually want to not do it based on the device, but not based on the browser or the device, but actually based on the content, use SVG or the object tag. That's a really powerful way of doing it. Okay, there's another trick, which is sometimes you have to have transparency in your images. And so transparency, you need a PNG 24-bit for it to look like a good JPEG. PNGs can be huge. I mean, they can be, like PNG 8s are great. They're the same size as GIFs, even smaller. But PNG 24, where you have good alpha transparency and many more colors so that it looks like a JPEG, can be huge. So in this example, the image on the right was 551K. And basically, it had this area that was transparent, and I wanted to show kittens in the middle of it. That's not actually what I was doing, but under NDA, I can't tell you what I was actually doing. So that is a transparent PNG, and that is huge. So what I did is I created a regular JPEG, just converted it to a JPEG, but it put a white background in. And so my white, my non-transparent JPEG was 88K. I already saved more than 80%, right? But I didn't have a place to put my cats. So what I did is I created a mask, just a black box that was 4 kilobytes that you could actually use SVG or data URI, make it really small without an X. And then I used masking. So here's an example of the phone is basically the frame, and it is a JPEG. So that middle of that image is actually white, and the JPEG itself is 20K. The original PNG of that phone was 133, and my mask is 0.3 kilobytes. And you'll see that it's actually transparent because I'm moving the cats around, because moving cats around is always very important. And the code is right there. All I did is I said, use the background image, use the image of the kittens, and then put a mask on it and make it, use the image of the phone, and then put the mask on top of it as a mask, and it just basically makes any part of the image that is black show through, and any part that is transparent not be transparent. Okay, so that's masking. So that is using CSS as a solution for better performance. But is CSS the solution? There's lots of tricks, like rounded corners. Native rounded corners is way cheaper than putting in rounded corners with images. Box shadow, text shadow, background position, background repeat, multiple background images, border image gradients, and using media queries. Those all reduce the number of HTTP requests. They're updatable, just using CSS. They're scalable. You can animate them. You have fewer DOM nodes, because when we were putting the 4 little corners in, we were putting 4 little divs in to hold the corners of our border radius. My trick is I never prefix. Well, that's not true. I do prefix sometimes, but I generally don't prefix my CSS, because the browsers that choke on it are Android 2.3. Notice I said plural, and then I went with a singular. Android 2.3 is the IE6 of our time. They're still selling phones with Android 2.3. The cheap disposable phones that people get when they're buying drugs. Did I just say that? I did. Those are Android 2.3. The old devices, the really cheap devices, are not Android 4.4. They don't support, still support WebKit border radius. Never put WebKit border radius, because all you're doing is setting the WebKit border radius only to Android 2.3, which kind of slows down to a crawl when it gets a border radius. Same thing with background size. Android 2.3 chokes on large images with a background size that's not auto. So if you don't prefix, you don't hit that old device. That's one trick. So we have some, that was a complete non sequitur, by the way, for my slides. We have several CSS features that will strangle your front end. In large fonts, and I'll describe what that is in a minute, I crashed an 8 gig computer browser. I crashed Safari on an 8 gig laptop by animating a large inset shadow. It's possible. So just think what that's doing on a mobile device. Gradients, I'll show you an example of a gradient that kills stuff. We already talked about background size cover. Sprites, great, not too large. One time I did I decided to put the 4 full background images into one sprite. That was way too large for the memory of the device, and it crashed. Non-rendered content is rendered because you're looking at a viewport, and anything that recalculates and repaints or reflows the UI. So here is what I meant by large fonts. It's actually small fonts that will use that memory. This will not crash your mobile device, by the way, but this is one of those little things that adds memory and you don't notice that it's happening. So just keep this in the back of your mind. So you'll notice that the top two, the top 3 are all 48 pixels, but the last one is the same as the third one, rendered. To make it look like the first 2, I had to bring it up to 86 pixels, the font size. So that's actually a small font that I'm growing really big, and in memory, it's capturing, basically the memory is an image of that whole thing, so it's 86 pixels high instead of 48 pixels high. So I'm basically as if I was sending these huge images to my mobile device. So this is not an end-all be-all, but just realize if you're doing this, that might be part of the problem, and think about it. Keep it in the back of your mind. So here's the same thing. These are both at 60, and I think I have to bring this one up to 160. No, I can't remember. It still looks smaller. I've brought it up by 50%. Let's bring it up to 120, and then I'll stop. Whatever. Yeah, that's about the same height for the lower characters. I had to bring it up a lot. That is now twice the size, using up twice the amount of memory. You see the difference? It's basically I'm drawing an image this big versus drawing an image that's that big. A little side note, use Font Squirrel. If you're going to use fonts, use Font Squirrel and only give your device the files, the letters that you need. There's right here, you can barely see it, but it says expert. And what expert, What expert allows you to do is custom, it's called custom subsetting. And you can actually tell it, I only want the ampersand. And it will create, you see at the bottom, in the blue, put an ampersand there, it will create a font file for you with just the ampersand. Now, if you're going to just use an ampersand, try using an SVG or a data URI of an SVG so that you're not creating the extra HTTP request. But if the only thing that is using a special font is the title of your company or your logo, that is a great place to only put the 9 letters that make up your logo. Okay. So when I was saying about Inset Shadow, this was actually the example that killed my browser on my desktop. I debugged JavaScript for 6 hours. But I animated, I was doing a runway, and I just had the runway blank with an Inset Shadow on top of it in case one of the images didn't load, so it wouldn't look boring. Now, the only thing that showed was the top image. you never actually even saw that Inset Shadow. But the way the browser renders, it renders from back to front. So it first put in the background image, then it put the Inset Shadow, and it had to measure every single pixel because there was opacity and transparency. So it measured every single pixel, and then it just placed another image right on top of it. So it was basically the measurement of that Inset Shadow animating. You have 16 milliseconds, 16 and 2/3 milliseconds to animate when you're animating. Anything slower than that is less than 60 frames per second, and that is the limit you have. It was taking more than 16.6 seconds just to render that Inset Shadow. So Inset Shadow killed it. I'm not saying a 3-pixel Inset Shadow is going to kill anything, but don't do something stupid like that. I'm teaching you from my own stupidity. It's not stupidity, but it's taking the browser and trying to not use. I refuse to learn Photoshop, so I try to do everything in the browser, and sometimes Photoshop just is more performant than CSS craziness. Text indent. We all learned to image replacement methods that shot content off the page. Difference between a desktop browser and a viewport on a mobile device is the viewport, you're actually just taking a picture of part of the page, and your web page might be this big, but you're only seeing this part. So when you have text off to the side at negative 99999 pixels, it's actually rendering that. So now you have this web page that is 10,000 pixels wide. Never thought of that. So instead, use CSS clip or position it a few pixels on the top of the page. You're never going to see it, but the browser is going to render it. This was the craziest thing I did. I discovered how to crash a browser using gradients. So I thought it would be brilliant, instead of using Photoshop, to put a gradient, because they just wanted this tiny little curve. So I did this radial gradient with an 8,000 pixel radius. And what happened is this. That is what was being drawn into memory. Now, you don't even see all of it. It's basically taller than this building. But it drew the whole circle in memory. And that memory was more than the browser had, and the browser crashed. So 1, it requires CPU to create. 2, it stores it in memory. Remember, the viewport thinks you're going to be moving things over, so it draws everything, even stuff that you don't see. And this is one of those times where an image using Photoshop would have been much more performant. Transitions, repainting. This is an example of having to reflow because I'm changing size. And this is an example of using transforms, which just repaints. It's a slightly different effect, but one is much nicer than the other. This is using transforms. So there was a trick, which is to use translate Z0, which is translating on the Z axis, just 0. And what that does is it takes whatever you're animating or moving and puts it onto the GPU from the CPU. We have a new thing in CSS called will change that is not fully supported yet, but you can tell the browser, instead of putting everything on translate Z, you can just say, we will change this. You don't want to do a will change star, a star will change or a star transform translate Z, because your GPU might render things faster, but it also has limited memory. So this is a great hack. Use it wisely. What it does is it takes whatever element it is, puts it on the GPU so the animation is smooth, but it does composite the image, which is using 4 times as much memory, but on the GPU instead of the CPU. So your mobile devices have very strong graphic cards, but you still don't want to abuse them. So I talked a little bit about Repaint and Reflow. Repaint is when you're redrawing a section of the page. So when you saw me transition with a transform, that was repainting. It was just repainting that div and growing it. When you saw me using font size, it was reflowing. It was pushing everything down, so it had to keep measuring the page. There's several properties that repaint. Visibility, colors, transform, background images, and transparency are just a few. Then there's I'm not going to be able to hit that slide. And I don't know why. It was working 10 minutes before I started my talk, but of course I updated my slides with this slide right here 2 minutes before I came in here. So there goes that one. So this is actually by AeroTwist. I forget his real name. He's AeroTwist but he's a Google developer evangelist. And what he did is he tested every single CSS property as to whether it repaints or reflows or does both or composites. And so this is a list of all the values. So what happens when things that repaint, let me show you an example of repainting, which hopefully I can get to the next slide. Yes, okay, so we're just gonna be off center for the rest of the day. This is an example of reflowing. So what happens is the page draws all the elements, and it draws it in order, and it's measuring everything, and then the browser is asked to change the size of something, and it will reflow, and it starts right there. It actually starts measuring everything again. You see how it's measuring everything again? So when you change the size of something, or when you ask the browser with JavaScript for the size of something, it actually reflows the entire page. Let's just get off of this, and I'm going to hit refresh, and hopefully that page just wants to be active. I bet it has an autofocus in it. Okay, well, there, that fixed it. Okay, so when you reflow, it remeasures the whole page, and one of the main ways that people do that people cause a reflow, not just a repaint, but a reflow, is by using JavaScript to get the size of something. If you change the box sizing of something, it will also reflow the page. Anything that changes the size of an element, everything, all the parents of that element have to be resized to make sure that it still fits, and everything that comes after it. So the more nodes you have, the longer it takes to do a reflow. So you want to minimize the number of nodes. There's two problems with nodes. Reflow is slower, and it uses up more memory. You want to cache DOM lookups, and you want to minimize DOM manipulations. So minimizing DOM manipulations will minimize the number of reflows. So minimizing number, you see, I have the notes there, and I already said all these things. So by batching DOM queries and DOM manipulations, whenever you write to the page, it causes a reflow. So instead of doing a inner HTML after inner HTML after inner HTML as you do a loop, just put everything into a string and then concatenate it or append child at the end. So let me give you an example of pooling and reusing. So this is a game of Tetris. I did not play this game of Tetris. I currently think I have the highest score on 2048. I am at 1,030,000, but that's insane. Don't do that. So apparently I'm a gamer. So someone played Tetris and got to the score of 3.4 million. Do you know how many rows that is? I don't. Line 666. Apparently this person was the devil. Can you imagine if they had created a different node, like a different div for each one of those blocks every time that they disappeared? Like, every time this grid is probably 10 by 25. So you need 250 divs, right? Not 10 by 25 by 666. So what is a smart thing to do, and Netflix used to do this, but they've changed their website and I haven't looked at it since, is they have a certain number of DOM nodes and they just basically pool them and reuse them. So create a pool of DOM nodes, and here it would be little boxes. Use the nodes that you created and release them back into the pool after you've finished a line. So this should only be using 250 DOM nodes, or probably less, and just repeat that. So the last thing I want to cover is UI responsiveness. When we're talking about mobile, and now also when we are talking about desktop and tablets and laptops, we are now talking touch devices. Who here has a touch monitor? Who has the Chrome Pixel? Just me? Oh, okay. So I have a laptop. I can touch the screen. My partner at the chiropractic office, you touch the screen. There's touch. Most of us think about touch as simply a mobile device. But one thing that happens is touch sometimes waits for the double tap. Depending, there is a meta tag that you can put in there which says don't zoom, and if you can't zoom, then it's not waiting for the double tap because it's not waiting for you to go like this and to zoom. But otherwise, it's waiting 300 milliseconds for that second tap. 300 milliseconds, when we were all 4 years old, 300 milliseconds was a really short amount of time. But now that we've been on the web for the past 20 years, we expect really fast reactions. 300 milliseconds is slow. 200 milliseconds is the amount of delay where you start losing customers. And here we're talking about 300 milliseconds just for the second tap. So this is the one time where I think it's appropriate to co-opt an event with JavaScript. When they click it the first time, and you know that, like, that's a link, just say, hey, they clicked a link, that is a touch, or they touch a link, co-opt that touch event with JavaScript. And when you do, your site might not, if you're doing an AJAX request, it might not pop up right away, right? You're not getting but let the user know that you have received their input. If you want to, like, give them some sort of feedback, whether that's a bouncy ball or a spinner, something, just a faded out button, that's the easiest way to do it, but give them a bouncing ball. They'd rather look at a bouncing ball than a screen and going like this because they don't think, they didn't receive any feedback. And when you get the feedback, then you can update the UI. So my pictures mean when they click it, say, yep, I got it, and then serve them when you're ready. Can you tell I'm not a designer? Okay, so a few tips in conclusion. Test on mobile devices. A simulator is not an emulator. Your memory is not capped. When you're on like an emulator on your computer, you're not capping your memory. Cap your memory. Go on edge. Because every single phone company advertises 4G. Who here gets 4G more than 80% of the time? No one. Who here gets it at least 10% of the time? Probably no one. It's all marketing. I'm on, it's pathetic what I get at home. Test with many apps open. I have testing devices, and I have to remember to install Twitter and Facebook and everything else that I don't even use on these testing devices because people have other things running in the background. If you're using a brand new device with no applications, that's not the experience that your users are going through. Your users are using up most of their memory for other stuff. Test on multiple devices. You don't have to test on every single device. It's impossible. And test on the mobile network. Use tools. I forget what scale down means. Oh yeah, scale down. Remember when I did that scaling of the text? When you're scaling images or using transforms to scale, take the full-size image and scale it down as your default, and then scale that back up, because it looks better. If you scale from small to big, you're going to get grainy. Take advantage of HTML5 and native storage, and don't disable your zoom, except for games. It's fine to disable zoom when you're gaming, because you don't want to click something and the whole thing move all over the place. But if it's not a game, if it's your airline's registration thing, don't disable zoom. Who here wears granny glasses? Oh, come on. So many more of you, thank you. I like my granny glasses. I wear granny glasses. I zoom in all the time for every single website that I go to. I actually, when I'm reading my website, this looks like it's done for a presentation. It's not quite that big when I'm reading an article, but it's almost that big. So let people zoom. Follow the performance recommendations, minimize your latency, manage your memory, manage the CPU consumption. Your user is not going to know that your website is the one, so you could be a jerk. Don't be a jerk. Or the word starts with the letter A. Use CSS judiciously. Realize that the browser is optimized for CSS performance, but there are some things, especially newer features, that are just not performant yet. Use JS minimally, and usually not for animations unless it's a very complex animation. Batch your query, like I was talking about. Minimize the number of DOM nodes. Reuse a DOM. And when you're developing, always realize that there is someone on a mobile device that is going to be looking at your site. They say design mobile first. If you're designing for, you're still supporting IE6, IE7, IE8, I recommend designing for tablet first. That way you have the default size is the tablet size, which is what most people who have IE6, IE7, and IE8, that's their size of the screen, because why would you buy a 24-inch monitor if you have such a crappy computer? Design tablet first if you need to, but always think of mobile. So remember, your users may not be tethered, and their memory might be limited. So that's all I have, but I do have this list at the end of people who are doing a lot in mobile performance that you may want to follow. So if anyone has any questions, I have no clue if I have time. I don't. I'm perfectly on time. Yes. No, if you have questions, I'm there. You know, the next session doesn't start for a few minutes, so yes. So the question's about HTTP2 and sharding, and the thing is that is not fully supported yet, so that is going to be like, I'm going to have to redo my talk when that is well supported and when at least 20% of servers and browsers are doing that. But right now it's just kind of a new technology, so this is to reach 99% of your audience. It's the best way to go, so this is still best practices. Anyone have, yes? So the question was, when do you use media queries and when do you use what? So you can use VH and VW for inside your media queries. So VH and VW, so for people who don't know, it's really old but just recently implemented. VH is viewport height and VW is viewport width. So you can actually base like your height of an element based on the width of the page, or base the width of an element based on the height of the page, which actually helps with centering, because you can use calc now too. So those would be very good to use in media queries. And instead of pixels, I prefer to use ems. So that way if someone, people understand pixels, and I don't want to go into too much detail on CSS, because that's an 8-hour lecture. But so there's a rem unit. Rem is a root em unit, and it's basically an em unit based to the base font size of the page. So you can also do it on rem units. And you really want to do rem or VH or VW instead of pixels, because you never know exactly like how zoomed in they are. And if you want your line to be 48 characters long, then you do like 28 or 30 rems instead of 420 pixels, because then you might have 3 letters on a line if someone's zoomed in like crazy. So yeah, VH and VW are definitely should be used in media queries. I prefer them to pixels, but so many people are no pixels and don't understand VH or VW. That's a good question, thank you. So if you have any more questions, I'm going to let the other people come in, and I will continue talking, but I will close my computer. Yes, what's your question?
I was going to ask about the Sencha image resizing service that you mentioned.
Yeah, let's take that offline. I'll talk to you about it. Any other? I'll be over here talking, okay. Thank you.